Hi all. See, this is a problem which is an advanced level problem, okay? And see that here it says that PQR are actually mutually perpendicular vectors, right? Now, what happened mutually perpendicular? That means that any way of combination we take, their dot product is 0. So first write down that info, okay? So here it says that the vector P, Q, and R are mutually perpendicular. So their dot product P dot Q is equal to Q dot R, and that's equal to P dot R, that's equal to 0. So any dot product you take that in any combination, that's okay. What is the second info? They says that they are having the same magnitude. So therefore we'll say that also this vector are having the same magnitude. So let us assume that mod of P vector is equal to mod of Q vector is equal to mod of R vector, and let us assume that K, okay, a constant K. So that's our first assumption. Now see that a vector X that satisfies this given equation, and X is also lies on the plane, right? So therefore we'll say that X and PQR are coplanar, right? So therefore say that as the vector X and PQR lies on no, that's not, maybe just see that. So PQR and X is not the appropriate logic. So let's go ahead. So see that P as PQR are mutually perpendicular. So any vector X can be expressed as the linear combination of the vector P, Q, and R. What that means? It means that the vector X can be assumed as x1 into the vector P plus x2 multiplied by the vector Q plus x3 and multiplied by the vector R. It's something like ijk, right? Because see that ijk are also mutually perpendicular, right? So these are the given info, whatever we write down and rewrite it in a maths form, right? That's it. So let's mark down that option. So this is the important info. We are having the first one, that dot product is equal to 0. And obviously the last one, that vector X is rewritten as in this form. Okay. Now see that what is given. You are given that X is equal to that X is a solution of this equation, right? Now see that playing with that big equation is not that easy, right? So we just calculate step by step. So first we take this product, right? P cross X minus Q and all that stuff. So let's consider that term. So let's consider that only that term. So therefore we find, let us take that P taking the cross product with X minus Q vector cross P. Now our job is to simplify that expression, right? So it's a, see that it's a vector triple product, right? Not scalar one. It's a vector triple product. So apply that formula with the dot one. So therefore you can see that it can be easily written as that if we rewrite that, you'll get P dot P multiplied by x minus q vector minus p vector dot x minus q vector, and it should be multiplied by that p vector. So that's the formula. Now see that what is P dot P? P dot P means that it's mod of P square. So therefore mod of P square we wrote in as K square, right? So therefore you can easily write down it as K square. Then x dot Q. X is also a vector, okay? And let us apply the dot product. If I apply the dot product, we get it as P dot X minus P dot Q multiplied by P vector. Now see that here we can easily write it is K square X dot Q vector minus P dot X multiplied by P vector. Why? Because P dot Q is already calculated as 0. So therefore it will be removed. So we are able to simplify it, right? Now our next job is to calculate that x dot Q and P dot X, right? If I able to calculate that, maybe we are a little bit simplified. Now see that in this particular case, right? Here I just missed the sign. This is minus, okay? Now see that P dot X, we already calculate the vector X, right? So if the vector X is calculated, we need to calculate what is P dot X. So therefore we need to take a dot product, right? So let's go ahead. So if I calculate that P dot X now, we'll get it as K square. Obviously we have the vector x minus q now and minus p dot x. So if I take a dot product of x, right, with p, we'll get that as, let us take the dot product. So therefore we'll get it as x1 into vector p dot p plus x2 and p dot q plus x3 vector p dot r multiplied by the vector p. Now see that it is obvious that this p dot q, this is p dot r, and that's equal to 0. P dot q and p dot r equal to 0. So we are not bothered about that. Again, p dot p gives me the k square, right? So therefore this problem can be now simplified as k square into x vector minus q vector minus k square of p dot p is k square x1 into the vector p, okay? That's it. So this gives me the x p square, k square. This gives me 0, this gives me 0, so k square and that. So therefore we are able to simplify the final value, right? So let's write down that. So therefore we can see that the vector now p cross product of x minus q cross p will be now simplified as k square x minus q minus k square into x1 into the vector p. That's it. So now see that similarly, using the same way of calculating all the remaining, we can go ahead and find out the stuff, right? So therefore by observing that, we can easily rewrite that q vector cross x minus r cross that q vector, that gives me as k square x minus r vector minus k square x2 into q vector. Then the last one, r cross x minus p cross that last one is r only, so r is equal to k square into x minus p vector minus k square into x3 and r vector, and that's it. So therefore, we are able to rewrite each and every term. So these two we can calculate similarly, right? Because we have to follow the same way, right? So based on that, we calculate. Now let's go ahead and add this term, right? So then we get that left hand side. So let's getting that adding all whatever we have. We just write down this part. So therefore, k square 3x minus the vector p plus the vector q plus the vector r, plus we can write minus k square x1 of vector p plus x2 of vector q and x3 of vector r. And that's obviously equal to 0. Okay, that's already given here, right? So now see that what we obtained. K square is a constant, so it can cancel both sides. So let's cancel out that. Okay, so if I cancel that k square from both sides, we'll get it as the vector 3x minus the vector p plus q plus r minus k square gone, right? Now what is x1p, x2q and all that? That gives me our x vector. So therefore we can find that minus x vector is equal to a 0 vector. So therefore by simplification we can easily calculate the vector x is equal to 1 by 2 p, q and r. That's it. Okay, and therefore for this particular problem we can understand that option B as the right choice. Only the tricks here that whatever we perform in the second step, right? Here we go ahead and find out this cross product, applying that vector triple product in the dot product formula and go ahead, right? But now this step we cannot perform again and again. So that's why we use that concept, that's maths we'll use, that's called similarly. Okay, so what's that meaning? See that. Let's explain a little bit on that. Okay, so here see that p cross x minus q, right? So therefore this time would can be like that, whatever inside that bracket, which be here multiplied by k square, right? Minus, right? We are multiplying by p, so that's why x1 component and p vector. Now here we are multiplying by q, so obviously that same term will come out with k square, x2 and q, right? And so on, right? So that's the tricks we have to apply. Otherwise you can go ahead and solve the same way for the second two and get that same answer, but which takes a lot of time. And that's it. Hope you understood the problem. Thank you.